So what is, as I said earlier, or in response to a question, what is my PASOE doing all day? So this webinar session is going to be about figuring out somewhat of a troubleshooting guide, figuring out where are your hotspots, what's happening. But just first an intro, if I can figure out how this works. There we go. My name is Peter Judge. I am currently an architect at Consultingwerk. I've been at Consultingwerk for probably 3/4 of a year at this point. I was working at Progress for about 20 years before then, working on mainly ABL, 4GL stuff, frameworks and applications. I did a bunch of stuff at Progress on PASOE migrations. I've worked on the web handler side of PASOE HTTP client stuff. And you can usually see me in these events, right? Progress communities, at PUGs, wherever. Consultingwerk software, who I work for, we're an independent consulting organization. Our main focus is on OpenEdge, although we do work on other technologies. Head office is in Cologne in Germany. We have subsidiaries in Europe, and I'm in the US, based in the US, customers largely around the world. As I said, we focus on OpenEdge applications, software architecture, and modernization. The various Progress products we have skills in, and we also do related things. One of our focuses, and that we're finding more and more need for, are DevOps, build chains, build pipelines, all of that sort of stuff, Jenkins and Ant and Gradle, all the fun things. So with that, as you can see, we'll talk a little bit about different ways of figuring out what's going on with your application, and work through that. Yeah. So in our applications, right, as everybody knows, there are always performance bottlenecks somewhere, whether you want them to be or not. And they're always hard to find, because usually it's just a ticket that says this screen is slow, which is not particularly helpful for you, the developer, who has to fix it. So finding those issues can be hard. I mean, sometimes they can be easy, but usually they're tricky. In general terms, if the whole application feels slow, where do you look? Do you look on things that run all the time? And so do you do tweaks on everyday code, as it were, or on kind of your batch jobs, right? Stuff runs once a month, your billing run takes 6 hours or whatever it is to run. Do you focus on that, given that it happens once a month or once a quarter or whatever it is? And kind of related to that is applications that use app servers, or primarily use app servers for data retrieval, data updates, whether that's in a GUI app or a web app, SOAP even, but different from those that use an app server kind of just to offload heavy work. Again, kind of keeping with that frequent code versus infrequent run of code. So again, deciding on where you want to focus there. And as a general rule, you want to keep your app server requests to be under a second. Otherwise, the user gets antsy or clicks close on the tab, and things just are not great at that point. You can just chew up resources on your app so that you don't really need to chew up. One way of finding these things is with a profiler. A profiler is great. It tells you exactly how long each line of code takes to run. And it's a really good tool to use to figure out exactly what's going wrong. The challenge with it is it's really, really detailed. It's very low level, and figuring out the correct level of granularity of this thing is too slow. You kind of know on the one end a request is too slow or a screen is too slow. And then if you look at the profile data, it's just this line of code is too slow. It has challenges in that it can report things that are frequently used as performance hotspots, right? If you have code like assert methods or logging or authorization or translation, they get lumped in with everything, and it can be tricky to pull out what is actually causing your performance problem. The other thing with profiling data is it's not always easy to visualize. I'm sure you've most of you who would have seen the PDSOE visualization of profile data. It gets the job done, but it's how do you know exactly what it is that's wrong? It may come to a line of code that says this line of code is slow, but often, as we'll see in a sec, there's context missing. So for instance, if we're using data sets and we use a fill method, right? That line of code that's highlighted there may come up and say that's taking 3 seconds to run, whatever it is. That's great, but what data set is that, right? What is the query behind that? Is there an analytics query on a database table? How many records are you getting? If you've got 100,000 customers, are you getting all of them, or are you just getting 10? Various things like that. Pro data sets of callbacks. Is there bad code in one of them? Is there is the schema of the temp tables, the size of the schema of the data set, is that huge? Is there lots of stuff in there? So it can be tricky to figure out exactly what it is that's going slow. Yes, the fill operation may be slow, but understanding why it is slow can be challenging. So ideally, what we want to do is kind of look on an app server, do profiling, and on an individual request level, right? So how long does this request take? And we can drill down into that. As we'll see in a sec, figuring out how long a request takes is reasonably simple. Where do you go next? So we can produce profiler files. Look a little bit in the sec about how to do that with PASOE, which has some advantages for profiling. But we can produce these really large profiler.prof files that get output. And they're very useful, as I say, very useful for figuring out exactly what is going wrong, but less useful for identifying which request, what the context is for the request, what the input data is to make that request slow. So the first thing we'll look at kind of in terms of monitoring is OE Manager. And the OE Manager is an optional web app. Optional because it doesn't always get installed on a PAS instance, and it provides kind of insights into your PAS instance through a web interface. So OE Manager web app is what OpenEdge Explorer, OECC, OpenEdge, I forget OpenEdge Explorer's other name, what that uses to talk to PAS instances to get the data and to do updates. You can also use it from any web client to do, to query data in the PAS instance. So it's got some monitoring through this get agent statistics call. There's an alternate, approach. The OE Manager kind of depends on this technology called JMX, Java Management Extensions, and you can use those from the command line if you don't want to run another web app. But we'll talk about how to do this through OE Manager today. So this is the Swagger OpenAPI UI that gets provided with PASOE. In the 12s, I believe it's turned on by default. In the 11s, it's there, but you've got to do some enablement of it, turn it on in a XML config file somewhere. That's in the knowledge base and the documentation, I think. And so what we can do here is for an application, for a particular agent, we can say, give us metrics, give us requests, give us data about this instance or about this agent, really. And that produces data that looks something like this. Here's my point. We can do a pointy thing here. Can I do a pointy thing? Pointy thing. There we go. So we kind of get a number of requests, right? Each of these JSON objects is a single request that the instance or the agent knows about. It tells us a couple of important things. The request procedure name. So you can see this one was used to log in, or a web request was made. Internal web handler request is the proc name, even though it's a method in a class. That's just the historical. You see which session it's on, and we can see request len here, how long it took, right? 93 milliseconds, that one took 377 milliseconds, that took, and a request ID. Those are all useful bits of information. This is a little less useful than it might be because all web requests use this same request proc name. So from kind of, this is a really like the high level view, all of the web requests, whether they're getting orders, whether they're asking for print jobs, whether they, whatever they're doing, they go through this same proc name, procedure name. It makes it really hard to figure out, which request was this? Was this get all customers, where, I don't know, credit limit, is, the modulo of credit limit 3 is 2, or some weird query that's going to run really slow, or is it just a normal one that goes fast? There's a challenge that we have to kind of figure out. Similarly, depending on the application architecture, you may land up with the same procedure name, right? So this is a .p, same kind of thing. The same procedure name runs through, right? So all we see from the outside is that .p. What is that .p trying to do? Who knows? From this point of view, who knows? So it's not particularly useful figuring out what is causing our slowdown. I mean, this is relatively fast, 48 milliseconds, but that may not be fast enough for your application. Profiling with OE Manager is easy in later versions or in PAS. There's a feature called server-side profiling that you can look up in the documentation. And that's really, really useful because it means you don't have to instrument your code, right? So by that, I mean, you don't have to put the profiler handle : enabled profiler profiling equals true, yada, 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 in blocks of code to turn the profiling on and off. So we can do this kind of with a poke from outside with a web request to the OE Manager web app. This data that it's produced as profiling data gets pushed to a different, or an OE Diag store web app that's deployed on a PAS instance. Could be on the same PAS instance, but that doesn't seem to make much sense. So typically you push that on a separate one, and that would keep the data. And from there you can extract the profile data and analyze it as you would normally. So this is the, again, from the Swagger doc, the various data we want to put in. So we want to look at, do we want to look at just web requests? We'll talk about these transports in a sec, but what do we want to look at? Do we want to look at everything? Do we want to just look at things that are faster than a time, things that are slower than a time, right? What kind of data do we want to look at? And that we push a JSON blob into, or document into the request saying we want that. Fairly simple. And of course, using the Swagger stuff is really easy to do. So that gives us profile data. Again, it's good. It's good for deep analysis. It's good for figuring out exactly what the problem is. It's less useful for figuring out where the problem might be, or what the context of the problem is. We can also look at log files. If you've worked with PAS, you know that there are many logs. You also know that they can get extremely verbose. The default location for them is in the instances logs directory. So there's an access log that says, here's a request. That's kind of handy because that says, what is the HTTP request and how long did it take? What was the status code on that? So that's useful for knowing this request took so long. That's got a URL in it rather than a progress class name or procedure name. Agent log is what you should be used to with AppServer. Is the same thing. Message about the individual requests that can hold stuff like 4GL trace, error messages, all sorts of stuff, fun things like that. There's an auth, and there's a typo there. There's an auth Z or an auth Z and an auth N log that can contain authentication and authorization errors and or events, depending on the logging level you put in, and a Catalina log, which contains Tomcat startup issues or some Java runtime issues, exceptions. So that sort of stuff. Typically, I find you look first in the agent log for stuff that is closest to the application's ABL code running. The others are useful for debugging problems, but generally you're going to look at the agent log. Access log, potentially agent log. One of the really useful things in OpenEdge 12 was Progress included a request ID to all of the logs, which is really nifty. It's there in 11.7, but not enabled by default. If you want to find it, the magic term is MDC logging, not request ID logging. It's a pain, but that's how we find them. And so we can kind of see from the access log, which is the first log that gets hit, all the way back to the agent log, this ID gets added in, root colon, A colon, and some value. And this is basically the web app, the transport. So the transport being what the client is. So A is APSV, W is web, S is SOAP, R is REST, and there's one with an F in it, which I found quite interesting, which is from the realm stuff. If we go back a bit, you may notice in here, root F, and I've not seen that before. Interesting. I'm not sure what the F stands for, but if you see an F, that's kind of what it is. It's from the realm. Right, so we can use that value really healthily to figure out a flow through all of the log files, which is really nice, kind of tying things together. It would be nice to be able to potentially create a log per request, so we need to have everything in one log, but that's not something that's supported in PASOE. Really useful piece of information because it tells us a whole bunch of we can debug stuff through. All right, in the logging, in the agent log, both in PAS and in classic AppServer. So I should just go back and say I mentioned this kind of stuff, these agent logs, this request ID, this is not available. This is only in PASOE. This kind of detail. The agent log is equivalent to the agent log or the server log in classic AppServer, classic web speed, roughly equivalent. AS plumbing is a logging level, which provides details about the request lifetime. So when did it start? When did it finish? How many bytes were read? How many bytes were written by the client? And this is available for APSV, REST, and SOAP, although not for web requests. So you can land up with lots of lines in the logs because the data is reported in 8 chunks. It says I got an AK chunk, I got an AK chunk, I got an AK chunk, I sent back an AK chunk. Excuse me. And the size of the temp table schema has an influence on that size as well. So if you enable this at a high enough level, you'll see a bunch of records like this. How much data was sent, how much was written. We can also see in the kind of, there's these start and stop, start and end success, right, messages. So we can see that's when that procedure started, this is when it finished, and you can kind of do a delta and figure out how long everything took as well. Again, log file tracing can be very useful. Putting in something like 4GL trace is also very useful, and you can see you get a better idea of the context of what the data is, right? Because 4GL trace can log the input parameters, the output parameters. It's a little less useful if you're using lots of objects because it just writes the object ID or the object handle, which is really what is passed, right? That's how objects get passed by reference. That value gets passed in and out. But that doesn't help you because you have no idea what that thing is, right? If you see a 1, 2, 3, 4, 5, I don't know what object ID, what that represents. And you can bloat your log files very quickly, right? And you really don't want to be the person who has to run out of disk space run out of disk space because you've turned on too much logging to try and narrow down one problem or try and figure out where a problem is. Okay, so coming into kind of approaches for figuring out how we can figure out what is slower or finding a request that is potentially slow. So there are a number of kinds of AppServer requests. I've talked a little bit about them. APSV, REST, SOAP, web, there's one called static. Progress documentation calls these transports. some of the APIs, call them transports. So if you get some data about a transport, you can get metrics on individual transports, etc. APSV is the old AIA, or the classic AppServer AI. It's used by ABL, 4GL clients and open clients, and this will always run a .p or an internal procedure. You can't run a class across over the wire from a client. The REST transport runs classes or .ps using a mapping that's defined in PDSOE, either annotation-based or with the mapping tool. It creates a thing called a PAR file, Progress Application Archive, that gets deployed into an instance. SOAP runs .ps. It uses proxygen mapping. The WSM is the same from classic to PAS, so that will run .ps. Web is new in 11.6, I think it was added, well, reasonably new, and that executes web handler classes. And to figure out which web handlers to run, there's some mapping in PAS configuration. There's a couple of ways of doing that. /static gets files off disk, so whatever that is. And there's no ABL involved. There's no agent involved in that. It's just pick up a file off disk, send it back to a client that asks for it. So those are the kind of requests we have. So you can think of those as, as I say, different client types coming into your application. Generally speaking, and this is really for APSV, for REST, for SOAP, you may call straight into a service directly. So a service in this case would be some kind of a business task or a business entity or a business service, some kind of business logic, right? Do the print job, do the tax calculation, get the order data for a customer, those kinds of things. That's our service. And generally, it's recommended to come in through a service interface. This becomes more of a practical concern when you're running with ABL clients. If you have your business logic in OO code, because you can't call from it, you have to call a .p on the AppServer before you can call OO code. So generally, in those cases, you're going to go through a service interface, right? Service interface does I'm getting a request from a web handler. It's coming in JSON. I want to turn it into a temp table to pass to my business logic. Once I get a temp table back from that .p or that class, I want to turn it back into JSON to pass back out again. So that's kind of its job. And that separates the client-side request technology from the business logic. As we've touched on, PAS will report the service interface in its metrics, in its data. So we always see that, as I said, for web requests, it's always that. No matter what URL you call, no matter which web handler you have configured, you will always see Progress Web, internal web handler handle request as the service interface. The first piece of code, the first piece of ABL code that's run on an app server is always going to be that. And that's going to vary. We saw a standard .p earlier as well. And this is kind of important to note when figuring out, we'll drill into it in a bit, to know when, what is that request? What is that web request doing? And so we have to kind of go another layer in, or another couple of layers in, to figure out what it is that's actually happening. So with that, we have Consultingwerk has had for a little bit some telemetry services that we kind of instrumented into our framework, and we have split that out into a kind of standalone toolkit that gets you relevant information, correct level of information about a request, so that you can figure out what's fast and what's slow. Things like which business logic procedure service was called by the client, what request did they ask, what was the for each they were asking for, any other specific details like that, as well as standard things like what's the request ID, how long did it take, who was the user, what was the service interface called, those kinds of things. There's a URL a little later with some more information, and I just wanted to note that the information I'm talking about here is going to show in the context of this telemetry toolkit, but also that the approach we took to build this toolkit or the service is, I think, easily generalizable, so that you can see kind of the concepts behind it, I think, are easily applied to all applications, I think is what I was trying to say there. All right. So as I've mentioned 2 or 3 times already, what's being called, right? So there's a service interface. Is it that handle request, or is it the web handler that gets called, right? So if we have a Consultingwerk resource web handler, there's a handle get method in there. That's also not especially useful. What we really want to know is it's the customer business entity and it's fetch data in that's being called. Like, we could infer some of that from the web handler, but as you build out your applications, typically web handlers get more generic, or they tend to handle bundles of functionality. So all requests to all business entities, so customers, orders, items, whatever it might be, will all run through that same web handler. So a handle get there doesn't tell us anything about actually what it is. The URL might, that could be useful. That might say /customers. But again, even then, there's kind of this abstraction between the URL and the business logic that runs. So that's the information we really, really need to gather. So that's one point. Another point might be, another piece of useful or good information is to have some kind of a key by which we can look this up. I touched on earlier, if we have a service interface, we can come in through different service interfaces into the same piece of business logic. So thinking about what it is we want to report on, what we want to figure out, is useful. It may be more useful to know that the business entity is slow rather than the service interface, although that would be good as well. Kind of standard instrumentation in here, I'll show you, maybe make it clearer with the next page. But kind of the kinds of things you want to track is, when does a request begin? When does it end? You want to know things like the service interface. That's good to know. But you also want to know what the business logic was called, right? Was it fetch data on the customer business entity? That's useful. And then you want to know a bunch of other stuff as well, typically, right? What are the queries being called? What are the input parameters into a method? That kind of data is going to give you the context of what you're trying to look for. So once we have this data, we want to be able to view it. We have as part of the telemetry toolkit a .NET GUI to visualize this. Just lets you kind of look at the data using, on your desktop. It can be useful for developers to just see, what the performance time is on various things. So I will just show you a little bit of that on how do we do this? Is that guy? On a B, that's what we want. So again, a GUI toolkit. I'm going to load in some, we've got some, not that one, that's kind of my file. And we have a bunch of, hopefully this is readable, data from various places. And so the nice thing about a kind of desktop tool like this is we can say, well, let's sort this by, we can just see, let's look by our key, group it by the key. Oops, and go back that way. And then we can kind of say we want to, in our runtime, not that, we want to look at the average and the maximum, the minimum, the count, right? How many requests were made? How long did they take? And so we can sort by that as well. Drag and drop, we can export that to Excel if we want to. And as I said, this is a handy development tool to be able to visualize that data. We also have some integration with In My Data, who you may know as previously known as Data PA. They're a cloud-based data analytics tool, and they've implemented support to import the output of the telemetry toolkit. Again, In My Data, I believe, yeah, as I said, cloud-based, and they have significantly nicer dashboards, nice visualizations of this data. And so we can kind of see, pull that data in on an ongoing basis, and we can kind of see what are our slowest and what are our fastest, average runtimes by hour, et cetera, et cetera, et cetera. We can work through a whole bunch of data. We can see here our average runtime. We've got 3 seconds for this particular web handler. I'll talk about the output in a sec. And so that can be very useful for being able to see what is, at a glance, what is slow. All right, so how is this all done? So at one level, there's a configuration file. Again, to kind of, you want to be able to turn this stuff on and off. You want to be able to configure different output locations, etc. Right? You want to identify the instance is particularly important here. If you want to, if you're running a bunch of horizontally scaled PAS instances, you're running 2 or 3 of them, one of them may be slow, the other 2 may not. So that could be useful to figure out, right? So how do we identify those individual instances? That's useful. And where do we want to put that data? How to do this? So the first place is kind of the entry point and the exit point of all requests, almost all requests in an app server, whether particularly in PAS, less so in Classic, are the activate and deactivate event procedures. And they give us a fair bit of information, right? So in the activate procedure, we can get information like what the .p was run, right? What the procedure was run, who the user is, or who Spring thinks the user is more accurately. We can get some other information in the start. In the deactivate, obviously, we can tell how long the request took. If we measure when did we start the request in the activate, we can figure out how long it took in the deactivate. So that's useful for really generic stuff. And we don't have to change any of our application code, any of our service interfaces or anything. We can just gather that information. And that information is pretty similar to what we saw earlier from the OE management request tracing. Stuff like user IDs is not in the OE management stuff, but a lot of information is similar. I say almost every app server request because certainly on PAS, if the exception to it is if you have a bound session managed, ABL client or APSV client, an OpenEdge client, but otherwise it always runs, right? And the reason for the bound is you don't have to activate. The thought was, I don't think you have to activate anything. You're connected. You have one connection. That's it, right? You're just talking on the same connection all the time. So that may be more troublesome. So again, in our world, we have a telemetry service we call begin request. We're going to on the activate, on the deactivate, end request, right? The begin request, everything's stored as JSON, and you'll see why when you talk about the output of this, it just makes it simpler. But we pull various informations. When did it start? The instance identifier, and then information from this OpenEdge request info object. So the first line up here, we get a current request info, and this is also available in Classic AppServer. I'm not sure when that was added in Classic, but it's always been available in PAS, and that's got a bunch of really useful information. It's got a client principal attached to it. So that is who in PAS Spring thinks the user is that's making the request. Now that may not be the same user that you have in your application database, but that's kind of Spring's context of who that user is. So if there's a client principal attached, if it's an anonymous request, or we don't have any authentication set up for that web app, it's going to be unknown or invalid handle. But we can get user ID, domain, we can get various information. We could get roles out of this. We could get sorted information from the client principal. We can also get useful things like the adapter type, right? So what type of client is it that's making this request? APSV, web, REST, etc. The agent ID, the session ID, and the request ID. So agent ID is typically going to be, in the PAS world, an agent has multiple sessions that can handle concurrent requests or simultaneous requests. And so we need to be able to know which agent is this running on and which session ID is running it. And that lets us, those two bits of information together with the request ID, lets us kind of trace this request back into the agent log, back into the other logs. And this is all just available from that request object and the progress version of the current request for information. There's a bunch of information that goes backwards and forwards. It passes, as I said, client type, client version, an identifier, a client principal. There's a whole bunch of extra information. As I said, this is pretty much a superset of what's available in the OE Manager APIs. So we can get that information off there. Just a note on get client principal on there, and this is kind of true anywhere in the ABL. If you call get client principal or get principal or security policy get, I forget what the method name is there, it will return you a handle, but that's a deep copy, right? And it's got information about the authentication, right? The client principals can tell you roles, username, domain, etc. Other attributes can get put in there as well. But the point is, just be careful if you do that, or whenever you do that, you need to delete it. They're not typically very big. They can be pretty small, only a few bytes at a time. But if you leak a few bytes on every request, sooner or later, that's going to bite you. So when you do get a client principal, make sure you delete it afterwards for whatever reason. You're not deleting the actual one that the AVM knows about, that's stored internally. It just gives you a deep copy every time, not a pointer, not a reference to that. It's a little gotcha. Getting a service information name, again, we just pull that off that request info, the procedure name. As I mentioned, that's going to be the same for web handling. For web handlers, it may be the same for APSV clients as well. If there is if it's a class that's called across the wire, it's going to have an ampersand in it, so it's going to have class name, ampersand, method name. So this just cleans it up. I've talked about this quite a bit. What is the service interface? And again, that's kind of the outermost layer of the request, the first thing that gets called by the client. On the end request, we are going to figure out mainly what the time is. We're going to set that key that I talked about earlier, which is kind of a unique identifier for this particular request. And we're going to write the data out. So we don't want to keep the data in memory for the whole length of the app server. We want to be able to write out at the end of each request, this is how long this request took. So we can kind of inspect that in near real time at the end of the request. And that's just what we've done. All right, so what do we have now? We kind of have more or less what the what PASOE's management gives us. Basically the same kind of stuff, a little bit extra around authentication or user ID, user details. But now we kind of want to drill down a level, right? Because we've just got the first level that we call. We want to get into the actual details now. Again, I've talked about this. If we call, customer business entity fetch data, whether we call that from a .p or we call that from a web request, we want to be able to treat those as the same call, right? They're going to do the same kinds of things. And so we kind of want to manage them at a level or report on them at the same kind of level. And this is just an example of kind of, especially if we have kind of standardized interfaces. So this is a service interface class. It's got a fetch data method. It takes an entity name, which is going to be, customer business entity, and it's going to take some context, some data around that fetch request. This is going to have stuff like queries in it. And in our include, we have a standard include, and in there we can say, okay, let us go and set that data out. So at this point now, we actually know a couple of really useful things. Firstly, what business service are we running? We're running customer business entity. We're not running internal web handler. Fetch data is the method we're calling, and we also were very interested in the queries, right? So generally, fetch performance is going to be query based, or is going to be caused by poor queries, especially if you have some kind of a query builder functionality on the client, or maybe even you don't, but the client code hasn't been updated to work properly with an index, or is a bug, or. So the query is a really useful piece of context about that. So now we have that data, and now that's kind of baked into various levels of the application. Sorry, I've got a comment saying no sound. Have I been talking into the void for a while, or is everybody okay with sound?
I'm okay.
Okay, you can hear me, right? Okay. Sorry, I just saw that comment. So at this point in our kind of instrumentation of the application, we've got the outermost details, we've got the next level in of details, which is kind of what we're really after. For web handlers, again, we have an include that does this stuff, and so in our include file, we get the same information, right? We get the service interface name, which is going to be the web handler name probably. We can store the URI of that request, so that can be extremely useful as well, right? There may be query string parameters or path parameters that are used to build up our queries, and we can record what the method is, right? So this set data kind of API gives us the ability to add whatever we need to. From a web request, what data can we get? So in a web handler, part of the data you typically receive, I should say, the part of the data you receive is a web request, and that contains all the information about that request. It contains the URL, contains the method, get set, get put, post, delete, whatever. It gets you the data that's being passed in, which is also very handy for write operations. There's a knowledge base link here on how you can get that information, but it's really useful, and there's some kind of helper methods on the request around things that are actually useful. So if we have a request like this, get localhost web app web service method, argument value. From the application point of view, typically, most of the time, 99% of the time, we only really care about /service /method and whatever follows afterwards. The host name, we may care, but probably don't. The web app, we maybe care, but also probably don't. The transport is kind of implicit, right? If we're running a web handler, we've come through the web transport. There's no there's no other way around that. So, there are some helper methods to get us that information. If we care about the web app path, there's a method to get that. If we care about the path info, there's a mechanism to get the PAS has what's called path parameters, so you can tokenize a path. So you can put curly braces for a piece of the path. We can get that information, all of that sort of stuff up. So that's really useful to know. So that was in the smart component libraries kind of implementation of, in the smart component library framework on the business logic receive, but not everybody is using that. So how about things like ADM2? I'm sure there's a bunch of people still using ADM2 backends, right? Whether they're on PAS, whether they're on Classic, or just, plain old various web handlers, just standard web handlers, I'll call them, or just running a procedure across the AppServer boundary. How can we instrument those? So again, let's look at ADM2 first. So ADM2 follows a kind of similar architectural approach to Consultingwerk in the sense that it also uses, when it gets data from an SDO or an SBO, but I don't know if anybody really ever used those because they were slow as molasses. So we'll just go with SDOs for now. Smart data objects. And they always call, for fetching data, these two, fetch data 64 was the first request, fetch rows with the subsequent request when you're doing batching. Commit was to save data, and call table was another approach. So you could call individual things across the wire. So how would one instrument this kind of an application? And in a similar approach, right? In our activate and deactivate, we're going to start and stop. We're going to get the standard stuff. But now we can kind of add code into those .p. So this is just a sample of fetch rows, how we would instrument or how we have instrumented that. So again, we need to know what that service request is. Knowing it's fetch rows.p doesn't help us at all. You'll see that this is just a preprocessor, a standard preprocessor in the ADM2 code, and we care about the base query and the query where, and we also care about how many rows we want to get, right? So if we want to get 1 million rows, well, of course, it's going to be slow. If we want to get 200 rows, maybe not. And then on the results side, we say, okay, well, how many did we actually get? That may be useful. If we got an error, can we add that in? ADM2 was written way before OO, so it doesn't have the concept of structured error handling, of catch blocks, of anything like that. So it used an output parameter. This POC messages is an output parameter with message text in it. And so what we can do is convert that into an error in our application code, or in our telemetry instrumentation code. So again, the same approach. This level is the level right at which, so this include file over here does the starting of the SDO, it does all of the things it needs to do. So this is kind of the furthest out in the application where we can get all the data we need to instrument this request. And so this can give us data that looks something like this. So the service interface we know is fetch rows, it's an APSV client. The service name though, that was kind of, is dtables.w is the SDO name. Buffer fetch contained rows is the thing. Here's the query we're going to do. Here's how many rows we want. Here's how many rows we got. Here's how long it took, and here's a key for it. Right. So we can if we were able to call this from a web client, which we may be able to, but we could then aggregate on that. So that's kind of instrumentation on ADM2. On kind of standard .ps, so we have a monthly tax calculation.p that we call from an APSV client. We call it calculate VAT internal procedure in there. And so again, this is the entry point into the business logic rather than the entry point into the request. And so we can instrument, again, outside begin and end. And now in this calculate VAT, we can now say, okay, well, what's pertinent here? What's pertinent here is the start and the end date. Making stuff up. Those are our input parameters. We could record on the way out how big the table was, is there data in it, whatever. This is clearly not a real business logic procedure, but the point is that we can instrument at this level, right? Again, as far out, as close to the initial calling point on the app server as possible, right? We could drill down and do a whole bunch of detailed information deeper into the application, but that's going to require a lot more instrumentation. And we really also want the telemetry kind of stuff, this instrumentation, this measurement, to be as fast as possible, as lightweight as possible, because otherwise, there's no point in trying to track slowness in our application when we're slowing it down by trying to track it. And that can give us something that looks like this, right? Same kind of output data in a JSON blob with whatever we passed in. We can measure how long it took, etc., etc., etc. Same kind of things. This agent ID over here is typically the PID, the PID of the agent process. It doesn't have to be though. It has a concept of a GUID or a GUID-like identifier for an agent, but typically people will use that. If we ran code like this on a classic app server, we would see, adapter type wouldn't be there. There's no such concept really. We probably wouldn't get the agent ID or the session ID or the request ID information. We get a pro version, and we would get some of this other information. The fun fact about the pro version is on an APSV client, it comes out as 12.6. On my web handler's coming. So on a web handler, you'll see it's slightly different, which is weird. All right. Errors can also get captured, right? That was just some bump code I put in there, but we can capture an error, so we know if an error happened, right? That may be useful as well. Error handling generically is tricky because PAS and classic AppServer don't have, so there's a standard entry point, right? Activate, there's a standard deactivate, but there's no standard error handler event procedure. And so each individual procedure that's called service interface procedure needs to do its own error handling. Errors will get thrown out into the log files, but we can't catch them generally. So we need to catch them individually and write them into our telemetry data. For a web handler, again, our service interface here is internal web handler. This include file over here, I showed you a little bit earlier, and that's going to capture things like the web handler name, the request URI, the request method, right? Because while it's standard to say handle get, if you know you're in handle get, you're typically going to do the get stuff. But it's possible to write web handlers where you don't have that method there. And so we can say, well, what do we want to do? Service request is, this is our, we've got a, should have shown the URL, we're going to do a print of some description. And so, you know, we have some job parameters, we have the print service and the print job. So it might be /print/ you know, today's orders. That's going to be our print job. And again, we can write that stuff into the, into our telemetry. So again, same kind of data. Adapter is now web. Our service interface, we've said it doesn't help us to know that it was internal web router. So we've set that to the web handler name and the web handler method. Our service name now is the print job and print service. And the fun thing with Proversion is in the web transport, they add web speed on the end of it for some reason. And again, whatever parameters we wanted to add in there, we can add in there as extra data. So that start equals now may be translated into a where string that gets passed down into a template, you know, it gets passed down, and we could capture that data. All right, so once we've got all this data, what do we do with it? And as I said, we want it to be fast as possible, both gathering and writing it out. And we want to make sure we guarantee the output. So you could just write everything into a single file. However, the output to statement or put unformatted or whatever, you know, those things don't guarantee don't guarantee synchronicity. So if you've got two sessions and they both try to write into the same log file, they will stamp on each other's feet. They may overwrite each other. So there's no guarantees that they will write out. That's just a general ABL thing. And so we want to make sure that we want to have some level of guarantee that we're not going to write on top of somebody else, because that's just doesn't help us at all. The telemetry toolkit writes a file output. You may choose to write that telemetry data elsewhere, right? Files are nice because they're a common API, if you will, a common protocol. You could write it to a database. You could write it to a socket, right? Send it to another server that knows how to do this. That's all eminently feasible. We chose JSON output because it's both machine readable and human readable. But on the downside, it's not really suitable for stream processing. So we decided to use what's called new line delimited JSON, which is a format which says, well, in a document, in a file, one line with one line per JSON document, right? So you'll see curly brace begin and end and whatever in the middle. And that's handy because you can just keep appending to the bottom of the file, and we don't have to open it, you know, we don't have to write a new file for everything. So we don't necessarily flood our file system with millions of files for each request. Each kind of session holds its own. So this data is the telemetry services JSON object, and we just output stream to that file name. One thing to note: if you're writing out JSON data and you want it to be ND, not line delimited, do not do pretty printing, because pretty printing adds in a whole bunch of line feeds. You just want to dump it out to disk. Excuse me. So that dumps all of that stuff to disk. And so those examples I showed you a little earlier, which look pretty printed JSON, they were a single line in a file that we just pulled out, pretty printed for the presentation. The kind of file name, and this is kind of approach we use this. Progress uses this in some of their also some of their kind of troubleshooting tools, the HTTP tracing and other places. Kind of tokenizes a file name. So you can you can guess what this is going to look, what this file name is going to look like. It's going to have an identifier, day, month, year, or year, month, day, timestamp, the agent ID, the session ID .ndjson. And this uses a class in the OpenEdge core procedure library, the token resolver, which knows how to resolve curly brace tokens. So it says, okay, well, I'm going to resolve request.agent because I know how to do that. That's standardized, timestamps are standardized, etc. And you can also plug into the resolver using strongly typed events, pub sub, or subscriptions to say, well, telemetry instance identifies not a piece of data that Progress knows anything about. That's a thing that my application knows about, that the telemetry toolkit knows about. There is a large number of tokens, from date timestamps to strings to user IDs to all sorts of things that you can use in general code. Really, it's just an ABL thing. They're documented in that particular link. So that's really quite useful for these kinds of things where we just want to say, let's get a new name for each file. We don't have to hard code anything. We can just configure that as we want. So where does that leave us? I think hopefully it's clear that we can gather a lot of data, like using just standard Progress tools with costs, mainly disk space. There may be some memory and CPU costs, right? So if we gather profile data for all the requests, if we gather all the logging for all the requests, we're going to have disk space problems sooner or later. They may have some memory impact and some CPU impact, and certainly cognitive load, right? Reading through, I don't know, 100 meg or a 500 meg log file to try and find that one request that's particularly slow is not fun. We can track some of the, or I should say, we can get a bunch of envelope or outermost data in PASOE, as I said, like very useful event. The activate and deactivate procedures are really key to a lot of this stuff because we can just write the code once and we can just measure some stuff. The knowledge, though, of what really is going on will require some digging into, or some knowledge of the application, right? Knowing what the structure of that application, of the framework you're using, whatever it is important. Especially when you've got kind of a service-oriented design, or you've got a standard 1 or 2 or 3 or 5 or 10, whatever it is, a small set of service interfaces that most traffic flows through, most requests come in through those service interfaces. So we have one web handler that does most of the CRUD work. We have one .p that does the read work. We have one .p that does the write work, right? Those are our service interfaces. And knowing that that's a slow point is not especially useful. Knowing the queries that we're executing is much more useful to us than knowing what the .p was. And as I mentioned, we have a standalone telemetry toolkit that can help with gathering all of these pieces, right? We've instrumented certainly our framework, but it can help you get started instrumenting your application. So with that, I will call that on time, 3 minutes over. If anybody has any questions, I'm more than happy to take them. If you have questions after the fact, feel free to email me. My email's not on here, but it's peter.judge@consultingwerk.com. Well, if there's no questions, then I will say thank you for your time. Feel free to contact me afterwards, and enjoy the rest of your day.